In this video, I'll show you how to prove a statement using properties of summation notation only. The question asks, let m be an element of natural numbers. Using properties of summation notation and without using induction, prove that the expression on the left side is equal to the expression on the right side. And we are not allowed to use these ellipses or phrases like continue this process because that assumes hidden induction and we don't want to use induction. Now before I start the proof, I have some known properties of summation notation underneath. And while 3 out of the 4 are relatively easy to understand and can be applied to this problem, working with the last one could get a little complicated. So we'll watch out for that together. Let's begin the process with the left side. Notice that we have in this expression, found within these brackets, two terms, sine I minus sine that expression. I will apply this property to split them. And here's what happens. So we have the sum where the index starts at 0 to an upper bound of m, sine I, minus, we'll open up another sum with the same bounds for sine I plus 1. Remember, we're only working with the left side and we want to transform that to look like the right side. This expression and this expression look very similar. So what I'll try to do is make sine I to look like this by changing the bounds of this summation. For example, if we apply this property, we can write I as I plus 1 if we are to subtract 1 from m and 1 from the index 0. So I'll write it down as sine I plus 1, but now the bounds have changed to m minus 1 and I is equal to negative 1. This expression remains the way it is. What I will do next is evaluate the first term of this sum at negative 1. If I evaluate the first term of this sum at negative 1, I end up getting sine negative 1 plus 1 plus, since I've evaluated the first term, we are now to the next number in the index, which is 0. So I have the sum where the index starts at 0, the upper bound hasn't changed, and the expression hasn't changed. This part also hasn't changed. Notice now we have two sums with the same index, and here we have sine at negative 1 plus 1, which is sine 0, and sine 0 makes 0. So we can ignore that moving forward, and we can focus on this part only. The next thing that I will do is factor out a negative from this term and that term, and rearrange it so that this term is first and that term is second. So I'll factor out a negative, and this term becomes positive, which I'll write in the first position. And this term, which is positive, becomes negative, and I'll write it in the second position. Now I'm only doing this for simplicity's sake, although you could leave it in their same positions if you like. The next thing that I want to do is make this upper bound of this sum to match that of m. But how is that possible? How can we do that? Well, you have to approach it in a clever way. So let's go ahead and do that. Let's make it as m and keep the lower bound the same. And remember that m minus 1 means the term before the last term. So if we evaluate the sum to its upper bound m and subtract from it what this expression is at m, so sine m plus 1, we will end up getting the same thing as the upper bound being m minus 1. Just think about that for a moment. This goes all the way to m, and we're subtracting the last term. It will give you the second last term. So this entire expression replaces that. And don't forget that negative, and everything else remains the same. Okay, now we will apply the distributive law by multiplying the negative into both of these terms. You end up getting two identical sum expressions that are of opposing signs, so they cancel out. And this one becomes positive sine m plus 1, and don't forget that negative out here. This looks very similar to the right side. What we have to do, well, first I'll remove these parentheses and just place that negative next to the sign. I'll apply an identity, which looks like this. Notice that if the angle is negative, you can pull out the negative and make it positive, and it will mean the same thing. So I'll factor out a negative from m plus 1. That's what it looks like. Then apply the identity where you have two negatives next to each other. So that out here, make two negatives next to each other, and you end up getting sine at negative m minus 1. That is equal to the right side, and therefore we have proven that the left side and the right side are the same. And there you have it. Now you know how to apply properties of summation to prove a statement. If you have any questions, leave them in the comment section below. Otherwise, you can use our website for further assistance. Thanks for watching.